Hello everyone, my name is Arvind Kumar Shukla. I am PhD student of the PNU University, and I am a student of the Professor Byung-Seo Kim. I would like to present the presentation here, optimizing designing of the vascular patch using in-bath bioprinting for improving the wound healing. So this is the content, introduction and research objective, experimental result and summary and future work. So here we introduce the introduction. What is the function of the blood vessel in skin? So skin is the blood supply come from the dermis, and the epidermis is the vascular get nutrient only by the different form of the nearest capillary from the loop of the dermis, and a deep network of the branches of the red kidney derived from the main artery is located in the deep to the dermis. Some branches from this network project toward the epidermis from the secondary red subcapillary. What is the wound? So wound is the injured part of the skin, and it is caused by the mechanical damage, chemical damage, and bacterial damage, and thermal damage and ultraviolet radiation. So what is the sign of the wound? Is the pain, redness, swelling and bleeding, and important of the function of the wound area. And symptom is the fever, malodorous pus, drainage and heat, particularly in the case of the infection. So research objective. So we are first here we use the 3D bioprinting, we use the PVA as a framework, and we use the Hubeck cell line as a bioink, and we use the in-bath bioink, and we designed the 3 different pattern, line, grid and dot, and then we use vascular pattern integrated skin patch, and then we can check the vascular skin patch in the mice body. So the experiment result is the development of light activated DECM based functional tissue specific. So first is the rheological behavior of DECM. So we use the 3 different kind of concentration of the bioink, 0.25, 0.5 and 1. So we get in shear recovery means stable maintenance of the print structure in the bath at the defined location. So 0.25% to 0.5% DECM group structurally unstable in the static state, and 1% DECM group maintain the rheological properties suitable to use as a bathing. So development in-bath vascular skin patch tissue model. So this is the schematic diagram of the line pattern, grid pattern and dot pattern. So this is the condition, experimental line, grid and dot, and cell line Hubeck, and volume of cell laden is the similar. This is the second result, parameter study of in-bath 3D bioprinting of Hubeck cell laden. So we checking the different pneumatic pressure 6, 9, 12 and 15 kilopascal of the line linear and dot pattern, and after optimizing we print the line, grid and dot pattern. So we here conclude we establish the resultant thickness and the diameter of the excluded bioink as per the different pneumatic pressure, allowing capacity to create the same volume of the different geometrical pattern. And this is the PCR result. So PCR result of the all pattern like a dot, grid and line. So we getting the grid pattern a higher angiogenic activity. So this result is confirmed that the grid geometrical pattern shows the higher angiogenic gene expression compared with the other geometrical pattern due to the higher complexity of the geometrical pattern. Therefore it is suitable pattern for the vascularized skin patch development. So summary here, according to the finding of this study, grid pattern of skin patch are significantly more vascularized than other pattern of the skin patches, and this process by which vascularized skin patch is implant in the wound skin regeneration under the physiologically relevant to the in vitro condition. It is significantly important for the chronologically wound skin tissue due to successfully regenerated by the vascularization of the skin. Future well, we following this study would concentrate to implementation of the vascularization in the skin patch in nude mice in order to enhance the regeneration capacity of the skin tissue. Thank you for my research work.